So far we've have finished or completed ionic naming. So ionic naming is between what two types of atoms?
Two non-metals.
Ionic naming.
Ionic is a metal.
Metal and a nonmetal. One from the right, one from the left. Covalent naming, which is what we just finished, is on what? Two of what? Two nonmetals. So two on the right side of the periodic table. So ionic is metal and nonmetal. Covalent is two nonmetals. So we're going to slide back a little bit to the ionic side. But today we're going to deal with acid and base naming. Okay, acids and bases. Can anyone give me kind of a general idea about what an acid or a base is? Acids in general, I'm going to give you kind of a pretty basic definition of an acid. And it's typically, or what we are going to think of it as, is a proton donor. A proton donor. What's it mean to be a donor of something? It gives it away. So it's giving away a proton. Okay, so I want to think a little bit about what defines a proton. What makes it a proton? Okay, it has to have a positive charge. So what element do we have that contains just one proton? Hydrogen. Okay, so hydrogen's most common charge is what? +1, right? Hydrogen's most common charge is +1, which means if we start out with a regular neutral hydrogen atom, we have one electron and one proton, right? A neutral hydrogen atom would have one electron and one proton. Would you agree with that? Does a neutral hydrogen atom, have any neutrons? No, right? Because its atomic mass is 1. So the only thing that contributes to its mass is its proton. Okay, so if we take its electron away, like it likes to do, right? It likes to give that electron away. It leaves us with an H+. And that is essentially, in and of itself, a single proton, right? H+, all this is a single proton. Okay, so when you see an H+ ion, it's essentially a proton. So when we talk about this transfer of protons between acids and bases, it means it's giving away a hydrogen or it's taking a hydrogen ion. That's what's happening. Okay, so in order for something to be an acid, to be able to donate a proton, what element does it have to have in its formula? Hydrogen. It has to have hydrogen. So acids must contain hydrogen. Okay, and I'll give you a little clue for acids is that when we have an acid, hydrogen always comes first. In the name. Okay, or in the formula, I should say, rather than name. Okay, in the chemical formula, hydrogen will always come first. So that's the clue for us that it is an acid. If hydrogen comes first, that has to tell us, oh, this is an acid, right? Because it's going to contain other elements too, and it might look like maybe it's two nonmetals or whatever it might be, but if hydrogen comes first, that's a really big clue for us that it is an acid. Okay, understood? Okay, so let's start looking at the different kind of types of acids here. We're going to focus on kind of two main types, but the first of which is called binary acids. What could you guess that these maybe contain? Or how many elements would you guess these contain? Yeah, these contain only 2 elements. Okay, and what does one of those elements have to be? It has to be hydrogen. So it's hydrogen plus one other element. Okay, this element, if hydrogen is a plus charge, right, it's H+, and another element, this other element needs to be a nonmetal, right? It needs to have a negative charge if we want it to balance out, okay? So we're shifting back to our ionic naming system a little bit in that these acids have to be neutral in their overall charge, Okay, so acids have to be neutral. Where covalent compounds, we didn't care what the charge was, right? Because it was two nonmetals, it didn't matter to us. With acids, we have to have a balanced charge. Okay, and since we're dealing with hydrogens, that makes it really easy. But we do need to have a hydrogen, which is a positive, right? It's a proton, plus some nonmetal, which has a negative charge to help us balance that. Okay? So in binary acids, it's hydrogen plus some nonmetal. It's a lot of the time a halogen, which is found in what group? 17, very good. Okay, so it's usually, a lot of times fluorine, chlorine, bromine, iodine, acetine, okay, are really the top four. But it could be anything that's a negative charge. Okay, so that's a binary acid. The second type that we'll talk about is called an oxyacid. So what do you think that has to contain?
Oxygen.
Yep, it has to contain oxygen. What else?
Hydrogen.
And hydrogen and something else, right? Plus one other element. Okay, and I'll tell you this even. Oxyacids are usually an H plus a polyatomic ion. Okay, so an example of an oxyacid could be hydrogen and phosphate, PO4 minus 3, right? We could combine those to form an oxyacid called phosphoric acid, right? And we'll get to that here in a second. But that would be an example of an oxyacid, would be H3PO4, right? Because it has hydrogen, has oxygen, and it's got one other nonmetal. Okay, does that kind of make sense? The difference between those two? Binary is just hydrogen plus one other element. Oxyacid is usually hydrogen plus a polyatomic ion. Okay? So you will need out your polyatomic ion cards if you don't have those, or at least your sheet that has your polyatomic ions listed on them or something like that, because you will need those today. Okay? So I'm going to give you a little sheet here, kind of a little cheat sheet to use for acid naming, and you will get to use this on all quizzes and tests. But this helps us identify how to name an acid. And the way that we do that is we base it off of what polyatomic ion did it come from, or what anion did it come from. Okay, so each person can have one, and keep this with your other kind of sheets that you would need day to day. But this helps us identify how we can name our acids. Okay, and so I'll kind of walk through a few examples, and then I'll explain what that sheet means in just a little bit, okay? So now that I've explained now that we know what each of these types of acids are and what they might look like, we're going to learn how to name them. Okay, so going back to binary acid, we know it's got to be hydrogen and some other element, right? Hydrogen and some other element. So the way that we name a binary acid, okay, I'm going to give you the little kind of formula for it first, and then I'll show you some examples here. But the way we name a binary acid is we say it's called a hydroic acid. Okay? So what do you think goes right here in this blank spot? Right, the element. So this is the root of the element. Okay, so this could be hydrobromic acid, which means I'm dealing with what element? Bromide, right? Hydrochloric acid, which means I'm dealing with chloride, things like that. Okay, so let's look at some examples here. Remembering that acids need to be balanced, let's say I want to build an acid between hydrogen and chlorine. Okay, I wanted to build an acid between hydrogen and chlorine. The good thing about building acids is that hydrogens are always plus ones. So it's going to be really easy to balance them, because it's basically how many hydrogens do I need to balance this negative charge, right? So if chlorine is a -1 charge and hydrogen's a +1 charge, how many of each of those do I need to make it balance? Just one of each, right? So when I put it together for my final formula, it's called HCl, right? That's it. I'm balancing it very simply because it's a 1 and a 1. So the name of this molecule would be hydrochloric acid. Right, so here's my binary rules. Hydroic acid. Chlor comes from the root of the fact that we're dealing with chloride. Okay, how do we feel about that? Okay, so far? Okay. What if I needed to form an acid between hydrogen and sulfide? Okay, so we need to look at our charges first. We know hydrogen is a plus, and we know sulfide is a -2. Okay, so you can do the cross method if you want. You can also just think about it in terms of, if sulfide is a -2, how many hydrogens do I need? 2, right? So that leaves me with a final formula of H2S. Okay, and so what would the name of that molecule be?
Hydrosulfuric acid.
Perfect. Hydrosulfuric acid. And it's hard for us to tell. There's not a rule that says why is this not named hydrosulfic acid, right? It's sulfuric, so you're really using the whole sulfur. That's not necessarily a rule I can help you with. So some of the elements use their whole name, some of them use just their root, and you'll just kind of get familiar with them as we use them. I'll kind of keep reminding you about which ones use what part of the word and things like that. Yeah, Jake?
I don't know, I figured it out.
Okay. So this leaves us with hydroic acid. So I want you to look on your little sheet that I gave you, your acid naming sheet, and see how on the first, maybe it's the last line on there, it says if it comes from an IDE, anion, then our acid is named hydroic acid. Okay, that's the one that we're looking at right now. That's a binary. So this right here, ide, is telling us that since we combine hydrogen and what is this ion called right here? What's this ion called? Sulfide, right? So if I take the hydrogens away from my acid, right, if I just was given this and I take the hydrogens away, that leaves me with S -2, right, which is sulfide. Not sulfate, not sulfite, right? Those are different things. This leaves me with sulfide. So this IDE is telling us that's how I named it, hydroic acid. Okay, is that making some sense or not so much? Okay. So hydroic, that means it's got to be just a binary acid, hydrogen and one other element. Okay? Let's try a couple here on your own. What if I gave you hydrophosphoric acid? Can you come up with the hydrophosphoric acid? Can you come up with the formula for that? Okay, hydrophosphoric acid. Why don't you try the formula for that? We know it has to be a combination between hydrogen and what? Phosphide. Good. How many hydrogens do we need to balance phosphide? 3. So did we have H3P? Good. Very good. Okay. All right, I'm going to try a couple more binary ones here. This is not just a greeting, right? This is an actual acid. So I'm going to give you 2 up here, one with the formula and one with the name. I'm not just saying hi, right? That's not just me saying hi. Yep, hydroiodic.
Oh, yeah.
Hydroiodic. That's a tough one. It's hard to know where the stop is, right, in the root. That's okay. As long as you were in the ballpark there, hydroiodic acid should have been what we had. So if you didn't have it quite spelled like this, just fix it so you know for the future. Hydroiodic acid. Did we at least have that on most of them?
Yeah.
Right, or close to it? Okay, second one, Nathan, why don't you tell me what you got for hydrosalinic acid? H2SE. Agreed? Good, perfect. Selenide is a -2, so you need 2 hydrogens to help us with selenide. Okay, feeling okay? All right, now it's going to move into a little bit more complex direction here because we're going to start dealing with hydrogen plus a polyatomic ion. Okay, so these are oxyacids now. Okay, naming oxyacids. These are the ones that are usually made from a polyatomic ion. Okay, so it's hydrogen plus some polyatomic ion. So there's a couple different things that we need to think about here, and this is where your sheet really comes in handy. Okay, it tells us that if it comes from an 8 polyatomic ion, right, if our polyatomic ion ends in ATE, examples would be sulfate, phosphate, nitrate, carbonate. You see where I'm going with that? All those end in ATE. If it comes from an ATE, our acid should be named blank ic acid. Okay, and that's on your sheet, so you don't have to put it in your notes if you don't necessarily want to, but you're more than welcome to. The other one is if it comes from an ite acid. Okay, so tell me again, what's the difference between an ate and an ite?
Ite has 1 less oxygen.
That's right, ite has 1 less oxygen. So if it comes from an ite, then our acid is named blank OUS acid. Okay, so that would be like nitrous acid, phosphorus acid, rather than phosphoric or hydrophosphoric, right? So these acids sound very similar. So it's really important to pay attention to the endings and to pay attention to our polyatomic ion endings. Okay, so let's try some here. If I wanted to look at hydrogen and sulfate, okay, you need to look through your cards and tell me what sulfate is. Or maybe if we start memorizing these, it would make it a little easier. Okay, sulfate is SO4 -2. So if I'm going to combine these and make an acid, how many hydrogens do I need?
2.
H2SO4. Right? And do I need parentheses here?
No.
No, because I didn't need more than one of my polyatomic ions. Okay, so H2SO4 is my final formula. The name of my acid would be sulfuric acid. Okay, and so it's not hydrosulfuric acid because it's not just coming from sulfide, it's coming from sulfate. Sulfate. Okay, so let's talk about how we can determine where it's coming from. If we just start with this, if we were just given H2SO4 to start, okay, which would be the case in most, right? If we were just given H2SO4, the way we determine what polyatomic ion it came from is we take away these hydrogens. So if I take away my hydrogens, that leaves me with SO4, and it leaves me with a -2 charge because each of those hydrogens was a +1 and a +1. Does that make sense? So if I take away those 2 hydrogens, it leaves me with this, and this is called sulfate, right? ATE. That's where I got this ic acid naming.
Would we ever need like more than one polyatomic ion for this naming?
You would never have more than one polyatomic ion in a single compound. Is that what you're asking? Oh, I see what you're saying. No, you wouldn't need parentheses, right? Because it's always going to be hydrogen at a +1. Yeah, good question. For acids, yeah, you would never need parentheses around your polyatomic ions because hydrogen is always a +1. So it's always how many hydrogens do you need, not how many polyatomic ions. Good question. Okay? Does that make sense where I got this ic acid from? Okay, let's try this one now. A combination between H and SO3 -2. Okay, so our chemical formula for this acid should be H. Go ahead and say it together. H2. Good. H2SO3. And the written name for our formula should be? Good. Sulfurous acid. Good. Very good. Okay, because this right here is not sulfate, it's sulfite. Okay, so the ITE tells us that our acid has to end in OUS. Yeah.
Would it just be like...
I'm going to give you the finished formula now, and you're going to give me the written name. Okay? Are you ready to try it on your own, or you want me to walk through this one? Okay? You try it on your own, I guess.
Chlorous acid?
Chlorous acid. How many of you would agree with that? Okay, good. So let's talk about how we got to that point. Chlorous acid, okay, if we take away the hydrogen, that leaves us with ClO2 minus 1, right? And ClO2 minus 1 is chlorite. Good. Was chlorite one that you made a card for? Yes. Okay, so chlorite's one if you made a card for. Even if it wasn't, and you knew chlorate was ClO3, right, that tells you that chlorite is ClO2 minus. Okay? This is going to be a mix of binary and oxyacids, so you can kind of jump back and forth between the difference. Okay, so I'm going to give you a few different ones here. Let's see. So I'm going to give you 3 different ones here. If I gave you the formula, you give me the name. If I gave you the name, you give me the formula. Good. Okay, I'm going to actually have it be called really phosphoric acid, but you are at least have the right ending, which is more important. Okay, so it should be phosphoric acid. And that's a tough one to kind of find the split, but if it goes with an R, or if it has an R, that's kind of a general pattern. So phosphoric acid. Okay, phosphoric. Did everyone have that? Or at least have the ic ending? Mm-hmm. Yeah, tricky. Mm-hmm. Because you want to just stop at the, I see what you're saying. Yeah, it's still phosphoric. Okay. No one had an N and an OUS there, did it? Right. Phosphate is PO4 minus 3. Good. Nitrous acid. Jordan, why don't you tell me what you had for nitrous acid? HNO2. Raise your hand if you agree. Perfect. Okay. Nitrous means it has to come from nitrite. Nitrite is NO2 minus 1, and hydrogen is plus 1, so they should combine perfectly to HNO2. Okay, last one, Eduardo. Tell me what you got. Hydrobromic acid. Perfect. Yep. Yes. Hydrobromic acid. So here we had 2 oxyacids and 1 binary acid. You don't really need to know, again, like the difference we were talking about between the 2, as long as you could understand that this came from bromide, which means it would hydroic acid. Okay. We feeling okay with naming acids? Are we ready to now jump? I'll give you all 3 types, and you have to pick ionic, covalent, or acid. Yeah. You're ready. You're ready.
I'm not ready to do it.
Okay. That's not what I wanted, sorry. I'm trying to make them tough.
Oh God.
Don't do that.
Whoa. Time
It has H first. Binary acid. Yeah, so whenever H comes first, that's your clue that it's an acid. If H didn't come first, then no acid. Yeah. Yep. Okay, so let's see here. All right. I'll give you an easy one to start out. Okay, you got 4 of them up there. The first one, ionic, covalent, or acid? Acid, okay. Second one, ionic, covalent, or acid?
Ionic.
Okay. Third? And the last one? Acid. Okay, so now let's talk about naming on the first one. McKenna, what did you have?
Hydrofluoric acid.
Hydrofluoric acid. Hydrofluoric acid. Perfect. Okay, because it comes from fluoride, hydrofluoric. Okay. Second one. Nice. Titanium. Did I spell it right?
Yeah.
Okay. Titanium 3. Good. How many of you remembered your Roman numeral before I even said anything? Good. Okay, good. Titanium 3 oxide. Anyone have questions about that one? Or we need to go over it? Okay, now's the time. Okay, number 3.
Trinitrogen dioxide.
Trinitrogen dioxide. Trinitrogen dioxide. Yeah, perfect. Okay, 3 nitrogens, 2 oxygen. Okay, last one. Jake, what'd you have?
Carbonic acid.
Carbonic. How many of you went 4 for 4?
I went 39.
Good. Good, good, good. Very good.
Take a break. 30 seconds. Take a 30-minute try. Is this still like anything?
Yep. Okay, easy. The first one, ionic, covalent, or acid?
Covalent.
Covalent. Okay. Okay, Henry, why don't you tell me what you had for the formula on the first one? S3Cl. I would agree. I'm going to guess that it's an acid, yeah, since it has acid in the name. Okay, Brady, you want to give the formula for the second one? BRO2. Perfect. Anybody get there? We had to search a little bit to find bromite, right? Bromate was on your sheet. BRO3 minus 1. And what's the difference between 8 and height? 1 less oxygen, that's it. So that's why we have BRO2 minus 1, and our hydrogen pairs perfectly. So HBRO2. Perfect. Okay. Strontium phosphite. Natalie, why don't you tell me what you got? Perfect. Perfect. Strontium is +2. Phosphite is -3. So if we cross those down, that leads us to needing our parentheses. So, right, is this 3 right here reducible?
No.
No, because it's part of the polyatomic ion. It is non-reducible. So can 3 and 2 be reduced?
No.
No. Right. No. Okay, calcium carbonate. Ed, stop. Rory, tell me what you had.
CaCO3.
Perfect. Okay, did anyone leave the 2s? Right, if we've got 2 and a 2, we should reduce them. CaCO3. Perfect. Anybody go 4 for 4 there?
I saw you
Good.
missed that one right there.
Okay.
That's